kind of started me off in this thing about Minnesota, thinking about some work that's been done to look at what the police department is doing in terms of these chokeholds and, you know, kneeling on people's necks. It just, as we got into the problem, it made me feel like it was too raw to talk about it. So I'm not going to use that example today. But again, from my perspective, one of the purposes of this class is that numbers can help us understand where there is injustice and where things are not fair. So, you know, you don't have to, there's no math involved to say a police officer kneeling on somebody's neck until they die is a terrible injustice and that person should be charged with murder. But that also is a function of the policy of the police department saying to police officers, this is an acceptable thing that you can be doing to suspects. And there's a lot of, if you want to research it, you know, I have some resources that you can look at that talk about how this is actually a nationwide problem, because that is a restraint policy that police officers can use in different places. But let's focus on per capita. That's the point of this, but I always try to make things topical, but I think that's a little too raw today. This is about Starbucks in different countries, okay? So if we want to know about the Starbucks per capita, that tells you that you need to do what?
Per person.
You need to, yes, per capita means per person. And so what are you going to need to do in order to calculate the Starbucks per capita?
Divide. Would you be dividing?
That's right, because you're going to make a ratio. That means make a fraction and then turn it into a decimal by dividing, okay? Now, I only want you to do the United States and China here. And just do the very first calculation here. Don't worry about the scientific notation. Don't worry about this part. We're going to get there. But I want to give you a minute to just calculate the Starbucks per capita based on what we just said. I'll go back to this real quick in case you didn't write that down. Make a ratio with people or population on the bottom, and then finish by dividing, okay? So go ahead and use this. This is on page
28.
28, yes, thank you. I don't know why this is not coming up right now. There it is. Okay, this is on page 28, and again, I only want you to do the US and China. I'm gonna give you, I don't know, a couple of minutes to do that. Okay, you need more time? You're not doing all 4 countries. You're not doing the per capita in scientific notation. You're not doing the per 100,000. Just doing the first 2 calculations, the United States and China, for their Starbucks per capita. Anybody need more time? Okay. So first of all, just in relation to what I was saying before, I would really appreciate it and love to hear your thoughts about whether you want to hear stuff with examples that are relevant to stuff that's happening right now in our society, in our country, issues that are, on point. Because in a way, when I talk about Starbucks per capita, that feels like, it's very neutral, but also like, who cares? Why do we care about Starbucks per capita? Whereas if we're talking about some kind of systemic injustice, if we're looking at per capita, it could really actually inform us about something that's happening in the country. But again, I'm not Black, so I don't know what it feels like to be kind of living it right now in this moment, having experienced things in society. So if you have opinions about whether you want to hear it or don't want to hear it, I'd be very interested. You can text me or email me. So let's take a look at the Starbucks per capita for the United States, and then let's look at it for China. So that's not the one I want. Okay, so these are, I should have hidden that first, but we'll get to that. These are the 2 representations of the ratios as fractions. Now, let me just point out that I didn't draw your attention to it because I was just checking to see whether you were going to notice it or not. But inside of this problem, there is a hidden word number. Now, I don't know if you saw it, but if you didn't see it, do you see it now? Where is the hidden word number that actually makes an impact on my mathematical calculation?
Is it where it says where the population number is in millions?
Absolutely. That's not next to the number, it's above the number. So you have to look at the table and practice. When you're looking at a table, you have to look for those things because it makes a big difference. Now, maybe when you did 6,530 divided by 300 and you got like 20, and then if you went as far as to think like, wait a minute, that means that there's 20 Starbucks for every person. I hope that you would say, that doesn't really make sense. There can't be 20 Starbucks per person. Also, this number is a hint because in Canada, the number was a very, very small number, 0.000 something, right? So you could also be expecting to get something similar to what they had in Canada. But anyways, that's very important. And then on top of that, the China example is a really weird million number because actually this number is not a million. What would we say for this number? Like, how big is this number?
Billion?
Yeah, that's actually in the billions. And so you might ask yourself, well, what the heck is going on here? Because I thought this was in millions. But if you look at China's number, it's actually 1,000 million people. It's 1,400 million people, and 1,400 million people, when you write it out, turns into a billion people. And again, that's one of the more challenging examples. A lot of people miss that and struggle with that. Both options that I gave you early on can be applied to do this successfully, but you just have to be careful about how you're doing it. So if you didn't get that number written out correctly, just put a star next to it and maybe make sure you get some practice with that. We can do a little bit of work on the side to make sure that you feel comfortable with how to write that number out. So once you have the numbers written out, then you can divide and you can look at the ratio. So there they are. Those are the numbers divided. They're both really small numbers, and that should not surprise you in a per capita situation, because a lot of times in per capita situations, you're taking something that's relatively small, like the number of Starbucks. I mean, I know Starbucks is everywhere, but it's not anywhere near as many as the number of people there are in this country. So when you make that ratio, you're getting a really tiny number. Now, if we try to circle back to our thinking about scientific notation, the process for doing that, again, is where you take where the decimal is and you think about where the decimal needs to go in order for this number to be somewhere between 1 and 10. So in this example, it would be here, but in this example, it would be here. And then you count how many places there are in between where you started and where you need to put the decimal. So there are 5 numbers here, and there's 6 numbers here, and that's where these exponents come from in the scientific notation. Why are they negative?
Because they're less than 10.
These numbers are very small numbers, and that's how I think about it. That's not the only way to do it. I think Becky talks about going left and going right. I tend to stay away from left and right descriptions and assignments because depending on whether you're putting the number into scientific notation or taking it out of scientific notation can affect left and rightness. And so to me, it's just simpler to say small numbers have negative exponents and big numbers have positive exponents. But again, if you're struggling with that part of it, we can get some more practice with that. The thing that I really want to spend a second on here, and by a second I mean a couple of minutes, is this next step in the table where we're going from this number to the per 100,000. Because if you think about saying this number in a sentence, it's not going to really sound very good. It's going to be something like, now remember, the third step in the process, I'm going to shorten this number up to 0.0002. The third step in the interpretation process is to put it over 1 and then extend the fraction bar. And then I put words in the top and the bottom. So this is Starbucks and this is people in the US. So my sentence then, well, I'll give you a second to think about what you would say and then I'll share my sentence. How would you turn that into a sentence? Okay, anybody want to try?
For every 1 person in the US or people, there's 2 Starbucks. Was that 2?
Nope, it's this number.
Oh.
And I can understand your impulse to turn it into a whole number.
Mhm.
But it's not okay to just ignore the decimal and the zeros, because that's not true, right? I
Mhm.
mean, if you think about it, that should sound a little crazy. That means for every human, there would be 2 Starbucks, right? That would be insane. That's a lot of Starbucks, way more than what we have now. Now, this doesn't sound good. It doesn't sound right. It is right mathematically, 0.00002 Starbucks for every one person. That is literally what the ratio is telling us. But what we need to do to talk about this, and what you see a lot when you're talking about per capita statistics, is we scale it up. And in this problem, they told you to scale this up by 100,000. So what I mean by scaling it up, it's right here, per 100,000. What I mean by scaling it up is you multiply the top and the bottom by the same number. So times 100,000 times 100,000, that's going to be equal to, well, go ahead and do that math. What's 0.0002 times 100,000? I'll do the bottom one. 1 times 100,000 is 100,000. So what is 0.00002 times 100,000?
Two.
Yep. The words haven't changed. These are still Starbucks, and these are still people in the US. And now my sentence is going to sound a lot better. For every go ahead. Somebody want to take a shot?
For every 2 Starbucks, there's 100,000 people in the United States.
Perfect. For every 2 Starbucks, there are 100,000 people in the US. And of course, you could have said it the other way. There's no right or wrong here. 100,000 people in the US, there are 2 Starbucks. Okay, so here's a good example. You see the y-axis label. This is deaths per 100,000, because when you look at the per capita rates for deaths, doesn't matter what kind of death we're talking about, there's not as many deaths by any measure that's anywhere close to how many people there are. And so when you look at the per capita rates, those numbers turn into really small decimals. So what they do to talk about it in a way that brings the numbers up into a scale that we can relate to is we make it per 100,000 people. So that's exactly the same thing we did here with the Starbucks. And this is a very commonly used tactic when talking about statistics, specifically involving death. Okay, so that last column then, I mean, really all that needs to be done to turn the number into the per 100,000 number is to just multiply by 100,000. But I wanted to show you this fraction part, because if you're going to then interpret that number and say what it means in a sentence, this fraction approach is still a good way to organize your thinking about what's happening and be able to talk about it in a clear sentence.